We are solving systems of equations today algebraically, and there's two ways to do that. The first is by substitution. These are the steps to solve by substitution. Solve for one of the variables, whichever one is easiest, or by itself. Substitute into the other equation, then solve the equation, and then substitute that answer back into an equation to solve for the other variable. Here's what it looks like. If this is my original system, this y is by itself to begin with, so I'm going to solve for y. Then I'm going to take this equation, and instead of writing y, I'm going to plug this answer in. I substitute it. I can distribute, combine like terms, solve for x. I get x equals 4. I take that 4, and I put it in here. I get 5 times 4 minus 3y equals 23. Only one variable, I can solve for y. Y equals -1. Here's my final answer. For -1, it's a consistent, independent system. The other method is solving by elimination. When you solve by elimination, you want opposite terms in your two equations. So you want a -2y and a +2y, or a -3x and a +3x. And you get those by multiplying one or both equations by a number. Once you have opposite terms, add the two equations together, and that eliminates that one variable. Then you only have one variable left, solve the equation. Then you go back and substitute to solve for the other equation. Here's what it looks like. Here's my original. I have a +3y and a +3y. That's not opposite. I need one of those to be a negative. So I'm going to multiply this top equation by -1, which changes every sign. I get -5x minus 3y equals +19. I add these together. -5x plus 8x is 3x. -3y plus 3y is 0. 19 plus -25 is -6. When I solve for x, I get x equals -2. I take that -2 and plug it back in. I solve for y, I get -3. Again, I have a consistent independent system here because my answer is -2, -3.